farm, it then became a waiting game. So I would have to find an individual defecating before I could pick up the fecal matter. Once I saw that, I would collect 5 to 15 grams of fecal matter and record whether it was a male or female and what age they were. Luckily, all of my farmers were extremely helpful with identifying all of these. You'll see here, this is a cow we collected from. You can see the manure on her behind. This one did have Cryptosporidium. You can also see here, this is diarrhea caused by Cryptosporidium. It's not your normal cow patty that you may be used to. So once I collected all of this data, I took my fecal samples back to the lab. I then performed a fecal smear, or a direct fecal smear, by taking a microscope slide and a micropipette and smearing a thin layer of fecal matter onto my slide. Once this was adhered to the slide, I used a modified Zeal-Nielsen staining technique to stain my slide. I use this because the Cryptosporidium oocyst walls are extremely thick due to their 4 main layers. And so normal gram staining, it doesn't affect them. That's why some scientists predict it took so long to study these protists. So I used the modified Zeal-Nielsen using carbonyl fusion, acid alcohol, and methylene blue. You can see here, these are my stained slides. They're gorgeous. So once I then stained my slides, I would go through and I would count the number of Cryptosporidium oocysts. Due to the carbonyl fusion, they were stained neon pink, so that was helpful. You can see an example here of a stained slide. And due to the fact that I'm not a parasitologist, I worked with a local veterinarian who taught me how to properly stain and identify these protists. Now when you look at this, you may not see anything that jumps out at you. But if you look closely, we have a Cryptosporidium oocyst. Here are a couple more examples that are zoomed in further. You can see these little coffee bean shapes. That's one way to identify them. That is the Cryptosporidium oocyst. That's what's making them have the diarrhea and all these symptoms. So once I collected this data, I then went to my results. So I originally said that Creek would have higher infection rates, and as you can see, they do. The statistical analyses are still being done for most of the data, but you can see there is a bit higher of a range. Now there's not as big of a difference as I predicted. So I talked to my faculty and some students, and we discussed that most troughs, they can still get fecal matter in them. Because cows, if you've ever met a cow, they're kind of dirty. So they get fecal matter on them, they can get it in their trough. Now there are some ways to mitigate this, and we'll talk about that in a little bit. Next, I wanted to look at age. So I grouped these into under 6 months, 1 to 2 years, and 3 to 5 years for the number of Cryptosporidium. And I originally predicted that calves would have less, and as you can see, that's true. But I found something odd. When I was looking at my data, about half of the calves had extremely high numbers. That's what I predicted. About half of them had extremely low numbers. So, in order to figure this out, I went back to my notes. One thing that affected them significantly was if they were drinking from their mother. And so if they were still, or if they had not been weaned yet, they were drinking from their mother, getting hydration from them. They weren't getting it from the creeks and troughs. That's why they had lower amounts. And that's why the ones that are just now weaned, they have those fresh immune systems and they're being exposed to it quickly. And then you can see the decrease over as age gets older. And finally, males and females. There wasn't statistically a big difference between these two as predicted. And then with these, we could possibly test more in the future. So what do we get from this? Well, we know that Cryptosporidium can be found more in creeks. We also know that the water source does have a significant effect, so possibly other water sources have similar effects. Age does play a key role, but not quite in the way I first predicted. And then gender, as predicted, does not have a significant effect. So what's next? As always, as a scientist say, collect more data. We can do further research into other variables as well. I did water source, age, and gender, but what about lactation, weather, climate, gestation periods? How does that affect it as well? All of this knowledge can be used to help farmers mitigate the infection rates and spread. And then finally, spread the knowledge. We can say to farmers, maybe block off your river and put up a trough. It's going to decrease their infection rates. And then studying further into how to properly mitigate trough water as well. I'd like to thank Dr. Paul Callow, my thesis advisor, as well as all the Mary Baldwin staff and students. Thank you to Dr. Reeser, who helped me to play with Cryptosporidium and to identify it properly. And then thank you so much to everyone for the whole process.